Hello everybody, welcome to the 12th tutorial in the series Learn and Bash Through Scripting. This is called Wheels, and in this tutorial we're picking up where we left off. And in the last tutorial we said we are going to solve the memory specified does not exist problem. Control X that. Let's put that here. And then let's return. Now what does return mean? It means give this function an exit value and return out of the function, which means exit out of the function. Now why would you use a return? The thing is, well, let's create a function called checkX. And let's say if $x is equal to, or let's this time use the dash equal, 5, well, then, we forgot the then, and echo x equals $x. Else, well, we're actually doing this totally wrong. So let's create another function, check x. And, wow. Function, check x. And if, are you kidding me? Okay, let's do this one more time. If $x is equal to 5, then echo x equals $x, and then return. Else, echo something bad has happened, or let's say just happened. And we phi, and then we echo no x, and then we close the function. Now what this would do is, if x is equal to 5, it will echo x equals $x, which is obviously 5, and it will return, which means it exits out of the function. Else, if x is not equal to 5, it will echo something bad has happened. It will exit out of the phi statement, sorry, the if statement, and it will echo no x. Now, although echo no x is out of the if statement, it will not execute if x equals 5, because we already told the function to return if x equals 5 and not execute the remaining the remaining of the function. So if we, for example, put x equals 4 and we check x, it says something bad happened, no x. And if we put x equals 5 and we check x, then it says x equals 5, and it doesn't execute no x because the function exits if this condition is true. So that's really what we're doing here. If a code matches some code in the file, then we remove the line that contains this code and then we return from the function. We don't execute the echo the memory specified does not exist. Else, if this does not happen, we really don't need the else here. And well, for every member it does this. And finally, if it doesn't find the code specified, it exits the while loop and it says echo the memory specified does not exist. Now this should work, or we are expecting this to work. Let's cat club9.bash, or wow, let's cat club.text, and let's bash club9.bash, and let's remove a member, and his code is, we already removed Adams, well, let's remove Bob, 10174, none was the better anyway, and there were both bad members. Anyway, so well, we are expecting this to work. However, this will only cause matters to be better, and it will say the updated file is now this. Well, that's good. It doesn't echo the member you specified doesn't exist, but then in the end it echoes the member you specified does not exist. And the reason this happens is that this while loop is executed in what's called the subshell. Now this is a shell. well, technically you can't see a shell. However, it's the thing that runs your bash commands. So whenever I say echo, it is the shell that runs echo, or when I say read-p, enter your name, and then I enter my name, which is, for example, called wheels, and then I echo $name. Wow, that's because I never read that into a variable. And like called wheels, my friend, and then I echo $name. Or for example, if I echo the date command, or whatever, if I do any other command, like for example cat club the text, what executes these commands is the shell. Now this the shell obviously has its environment variables, and for example it has the $random, and wow, did I do this? It has the $random 25881. It has its random variables, and it has its variables in the program. So this so when we run this program, the shell gets all the variables in this program. However, this while loop is not executed in the shell since it is piped. It is executed as a subprocess and executed as sorry, excuse me, as a subprocess in a subshell of the shell. So a subshell takes its own copy of all the variables. It doesn't really change the variables, or it doesn't really know that it's inside a function. It just knows that this is a normal subshell. So what I mean by this is this whole block of code doesn't know that it's inside a remove member function. It doesn't know anything since it is in a subshell. It's not really in the parent shell that this program executes on. So when we return, it says, hey, you should return, but well, we're not in a function, we are in a subshell. I don't know that we are in a function. I only know my subshell environment. And that's why return doesn't work here. And well, guess what? We may be able to use the variable as the breaker, just like we used in the until. So we'll, for example, say got it equals 0. And if we found the code, then got it equals 1, else got it stays 0. And then we're going to copy this statement, Control X that, and if got it is equal to 0, then we paste it. And well, let's get this little guy over here, tab, and then we phi. If got it remains 0, then that's dash equal to, if it's equal to 0, then the memory specified does not exist. However, if it changed to 1, then the memory specified does exist, and this does not get executed. Now, would this work? Bash club 9 dot bash, and let's really register Bob again. I don't remember his age, but well, let's say 32. And then, sorry if I have set you to bronze while you were gold, and Adams was 14. Cat club dot text, cat club dot text. Yeah, that always happens. Cat club dot text. Excellent. And if we bash club 9 dot bash, and we try to remove a member, and that's Adams 20249, we see that the same problem persists. And wow, that's because, are you kidding? Daughter got it, and what happened? Unary operator expected. Sure of a thing. Daughter got it dash equals, actually, what was the error here? 0. Got you. And well, if we bash club9.bash, and well, we're going to register, that was shameful. Adams, not Admas, Adams, and his age is 14. Now we're going to get club the text. Adams really has a hard time dealing with this club. All just gets removed, and then all just gets added, and then we're sorry Adams, you're removed again, and then well, you're added Adams. So remove, and let's say 9989. We see that the updated file is this, however, the same problem persists. This is because the subshell also gets its copy of all the variables, so that gotit is never known, or it's never known outside the subshell. To demonstrate this, we're going to say, let's say members is a variable and it equals to 0. Now while members is less than 10, do, and remember that we use double parentheses so that we can use the normal less than and greater than instead of dash lt and dash gt. So we say members equals members plus 1, and then and that's used for arithmetic calculations. So that's members plus 1. We can't say this, we can type this after the equal. We must use an arithmetic calculation, which is dollar parenthesis parenthesis, and then really the spaces here don't matter. And then we're done. And well, we echo members, and we're done. Now we see that members becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if we in fact echo members, we can see that it is 10, although we have started with 0, because the while loop effectively incremented the members variable until it reached the 10. However, if we put members equal to 0 again, and let's cat club.text, and for every person, for every member in club.text, while read line do, for each line increase members so that members becomes dollar excuse me, members plus 1, and echo dollar members, and we're done. It says that's 1, 2, 3, 4, 5, 6 because we have 1, 2, 3, 4, 5, 6 members. That's correct. If we do echo, however, the value of members, it's still 0. This is because when acting in a subshell, a subprocess gets its own copy of variables and never really update the original variables. And that's why gotit remains, well, actually gotit is not even known outside outside the subprocess, because we initialized it in the subprocess. And well, if we even do initialize it outside the subprocess, then the subprocess gets its own copy of the variables, as we saw with the members, and really never updates the original gotit, and then gotit stays 0, and this if block executes. So that's why we could never use the variable, and we could never use a return, because this is created as a subprocess acting in a subshell. However, there is a turnaround. What if we can use the return statement, but instead of making the while loop a subprocess, we only make the cat club.text a subprocess? So we're going to remove this piping and then say while done treble angle brackets, and that's the opposite of the double angle brackets used for file output, and we say cat club.text. This effectively means run cat club.text as a subprocess, but run the normal while loop as a process, as a normal process in the parent shell. And here we can really use a return, because that will return out of the function, because now the while loop knows that it's inside a function. And we can say the member you specified does not exist. This will happen only if the function doesn't return, and if the code is there and it is removed, then this echo is never executed because the function returns. Now let's cat club.text one more time, and great. Now let's bash club9.bash, and wow, that's because, yeah, really, I always forget that. But when running this as a subprocess, we need to put that between quotations, and we use the command substitution method. and here cat club.text, and we bash club9.bash, and then it says, well, what do you want to do? Well, let's remove a member 2159, and then it says the updated file is now this, and the function returns before executing this, and that's why echo, the member you specified does not exist, doesn't get executed. And the bash club9.bash, well, let's say, now let's try if the logic is really fixed. Let's say 53, and let's see if it does remove Martin. And it says the member you specified does not exist. If we cat club.text, we see that Martin is still there. Now, really, this is not suitable for an if statement. It's not nice to do this in an if statement, especially with this semi-complex block. We don't do the modifying in the if statement. We can remove all of this and say if this is equal to the line, and modify the line here. So we're catting club.text, and while catting we cut -d for each line, and we use the field 2. We actually can concatenate these, and we trim -d the space so that everything is done in the sub process, and then the while loop executes this one, and the line is already modified in the sub process. We don't have to modify it in the if statement. This makes the code more readable. Now if we cat club.text, we're going to remove the last new member, which is Joan, and we're going to bash club9.bash, and then remove a member, and let's say he is 2859, or that's 957, and it says the updated file is now this, and Joan gets removed. If we do try our old Pitfall, which is for example 46, the member you specified does not exist, and the logic works fine. Now, this is really an interesting piece of code, and it's very interesting that in fact I'm going to comment it and not remove it from the program, just to show how much we have, how much pain we went through just to fix this logic pitfall. And I already said that in club8.bash there was a very easy solution that we could have used, which is just modifying the if statement. And the reason I didn't use it is, just as I said, for exercising dealing with logics. We learned about subshells, we learned about subprocesses, the triple angle brackets, and we learned about modifying using the cut-d, trim-d, and we learned a bit about piping. So we learned a lot of things while dealing with the logic. We can go here and cat club.text, and there is a tool, well, actually it's a full programming language for modifying text and dealing with text. So we can tell Oak to print the second column, and the column in Oak means something after a space, so that this is the first column, this is the second column, this is the third, this column is the fourth, this is the fifth, sixth, seventh, 8th, 9th, 10th, along with this column, of course, and that's the 11th line. So we only want the second line, and we want it to be printed, or to get this from club.text. We can see that we have a slight problem, which is the colon. We can effectively remove this colon using tr-d. We remove the colon, and we only get all the codes. So that's the same as catting club.text and cutting -d using the delimiter at the field 2, and then trimming the spaces. That outputs the same result, but that's using Oak. So if we Oak here, and let's really remove this. If we Oak print the second column from club.text and remove the colon character, and yeah, sure, there you go. And after doing all of this, we grep from the result if the code is already there, we remove the code, and if it isn't, then the member specified does not exist. This way we're only comparing codes to codes. Then the program works fine just by modifying the if statement. We're going to see this cat club.text. Now let's really remove Martin. So that's bash club9.bash. And to remove a member, let's say he is at 17.819, and then it says the updated file is now this one, and yeah, the member specified does not exist. This happens, sorry, script /q $code. Let's add the member one more time. Martin at age 17, and let's go hash club9.hash. And then we remove, well, let's first cat the file, and then execute that and remove him. He's at 49.26, and then it says the updated file is that. Well, else the memory specified does not exist. This happens because for every line it happens that, yeah, because for every line read here, it says the memory specified does not exist. It really relates to a logic pitfall, another logic pitfall, which is instead of, if you can track back this whole if statement, what it does is it prints the second column, a club.text, and tr-d the colon, grep-q the code. So it really searches. So if I go here, bash club9.bash, sorry, or let's really, well, if we track the if statement, we can see that it's totally fine. This is OK and grep-q, but what is the error here? Well, the error is actually, if you notice the error, you'll feel like, hey, that was very easy. I'll give you 10 seconds to really scan all the remove member function and to see what the error was. So you have 10 seconds. Great. So I do think the time is over. Maybe I'm a bit too early. But anyway, the if statement itself is totally fine. We just forgot to comment that echo. And that wasn't a logic pitfall. That was a logic pitfall, however, because we forgot to comment something, and that is a logical error in the program. So that if we, please get club.text, and if we remove a member, register a member, and that's Martin at 14, and we register another member because we're now celebrating our victory over the logic pitfall, and let's say his age is 22, and then we get club.text one more time, and then we bash and we try to remove the member. It's 17, or let's say 14.836, the code for Martin, and it says the updated file is now this, and it has successfully removed Martin. Of course, we can do this. We can take this whole if statement, Control-C here, and put it here, so that we also fix the access member function. And this way, the access member function and the remove member function, their logic is now fixed, and everything is ready for continuing the club.text and taking it, the club program and taking it to the next level. So we really learned a lot of things here: the subshells, processes, subprocesses, return, and well, we also used the awk tool. We used the cut and trim. We talked a lot about the executing subprocesses using the triple angle brackets, and that's really everything for these tutorials. I hope you really enjoyed the 11th and 12th tutorials, and until the next tutorials, guys, see you later.